one of the lessons that we've learned from Fukushima, and in fact we've learned it from Chernobyl and 3 Mile Island before Fukushima, is that in all of these cases, the driving forces for failure were what engineers might consider as the soft stuff, the organizational failures, the institutional failures, the regulatory failures. And this raises an important question about whether the countries that are considering embarking on nuclear energy programs or are already in the early stages have the institutional robustness to avoid these kinds of soft failures, which really are not soft at all. They're at the core of the problem. And so when we look at this group of emerging nuclear energy countries, we have to be concerned about both the technologies that they will adopt and the organizational and institutional structures that they will introduce. And I think for engineers in the nuclear field, people thinking about the next generation of innovations, we have to be thinking about technologies, both new reactor technologies and fuel cycle technologies, that place fewer burdens on institutions, on organizations that build and operate nuclear systems. And that, to me, and I think to many of my colleagues, points, for example, in the direction of greater and greater emphasis in our designs for nuclear systems on passive safety mechanisms, to the point where, you know, in the ideal case, we think about and should be developing so-called walk-away safe nuclear reactors and fuel cycle facilities, reactors in particular, which would have the property of, you know, in the worst case scenarios, such as the earthquake and tsunami that we saw in Japan, it would be possible to do what, unfortunately, the Japanese operators at Fukushima could not do because of the characteristics of the reactor technology, and that is walk away and let the reactor shut itself down and cool itself off after it shuts itself down. Is it so implausible to imagine that 30, 50, 75 years from now, this feature of walk-away safety will be a requirement for all new nuclear power plants? Of course, we don't know, but it's something that we need to be thinking about today, given the very long lead times for the development of new energy technologies, including new nuclear technologies. And so as I think about the future for nuclear energy, one of the things that I think about is the difference between the Model T Ford of 1913 or whenever it was introduced and a contemporary luxury automobile. Both vehicles are identifiably automobiles, but there is, of course, an enormous difference between the two in terms of the technology and the capabilities of these vehicles. And I think as we look at today's nuclear power plants and think about the nuclear power plants of the year 2100, I think we will see, I won't be around to see it, neither will neither will you, but I think we will see a comparably vast difference in the capabilities of the reactors of the next century. I think the students in the nuclear science and engineering department have always recognized and been faced with the fact that they work in an area which attracts a lot of public attention. And so the ability to communicate in the public domain, not just in the area, not just among their technical peers, but to the members of the public, has always been understood to be an important aspect of education in the nuclear science and engineering field, probably more so than most other fields of engineering and science. But this recognition really was hammered home in the period immediately following Fukushima, when there was a tremendous demand for reliable, technically reliable, understandable information that wasn't being provided by for the most part, by the networks, the news organizations. And our students stepped forward at that time, and through a medium which simply wouldn't have been available, wasn't available even a few years earlier, set up a technical blog in the days right after the accident, and communicated to, in fact, more than 1 million visitors to their website in the few days in the week or so after the accident, communicated what was going on in ways that were accessible to people who didn't have technical expertise in the area, but who were deeply concerned about what was happening, and in many cases considered what was happening as a matter of life and death. And our students in real time were learning about what it takes to communicate information in a way that members of the lay public can understand, and what it takes to maintain credibility, and what it takes, what would happen if credibility were lost, and how to maintain credible communications that could be believed at a time when there was, of course, great confusion and many doubts about the reliability of information. And certainly during that period, immediately following the accident, the second largest group of visitors to our website came from Japan, where, as you know, there were many difficulties and failures in the communication of useful technical information. So, of course, our students weren't the only ones who were trying to provide these kinds of services, but I think it was a remarkable contribution that they made, and it was an education in real time about how to communicate effectively complex information with literally millions of people looking at them as they were in the process of learning this. So it was really quite an extraordinary experience for them, I think.